Okay, so layer 3, network layer. This controls the operation of routing and switching to different networks. So it's using the network layer that subnetworks are created. This translates logical addresses or names to physical addresses. So as a user, I go to www.microsoft.com. The network layer is the one that translates that from that address or from that name to an address.
So when this happens, since we've already gone over the first two layers, we could talk about this now in a broader context. I want to go to www.microsoft.com. I do that. There's a process in the background that goes on that sends an IP back to my computer. It says that name has this address. And here we see Internet Protocol as the network layer protocol. There are services that will translate the name to the number. Like we just talked about in layer 2 with MAC addresses, there are also services that translate that IP into a MAC address. Or throughout my network, ways to figure out that that MAC address isn't on my network and I need to route it out somewhere else to find it. So this name translation or number translation happens at multiple layers. It's another one of those things I was talking about where the packets are being modified as they go up and down. Each of those layers has protocols and applications within it that are doing things to make sure those packets get where they need to go.
Devices that work at this layer are routers and IP switches. Network layer components include IP addresses and subnets, and the unit of measurement at this level is packets. So we talked about layer 2 switches. Layer 3 switches are basically switches that work at the network layer. So now instead of using the MAC address, we use the IP address. They have the same functionality, they just work at addressing at a different layer. Layer 4, the transport layer. So we've talked about the physical layer, the data link layer, the network layer. Now we're going to talk about the transport layer.
I'm sitting here listening, making sure he gets them all right. As we're going through,
Christopher's
he's just throwing these
testing
out
me.
of my mind. We'll see how it goes.
This layer ensures messages are delivered error-free and in sequence with no losses or duplication. Protocols at this level perform segmentation, ensure correct reassembly, and perform message acknowledgement and message traffic control. So if I have a 10-page document, and with this 10-page document, let's go back to our postcard analogy. I have a 10-page document, and I can only fit 10 words on a postcard, and postcards are how I need to transmit information to Christopher. So as this goes down the stack, at a certain level, the transport layer, this 10-page document starts to get cut up into different smaller bite-sized pieces. These get put on postcards. When they hit the network level, it says, oh, and another thing that the transport level does is, so now I've cut all these up, I've put them on postcards, well, I number them. I say, hey, this is number 1, this is number 2, this is number 3. So when Christopher gets this information, he can reassemble in appropriate order.
And make sure I'm not missing any.
Exactly. So, do my postcards, network layer, I address them, I get to the data link, that's me walking to the post office box, opening the mailbox, and then the physical is me throwing it in, and then the mail carrier handing those off to Christopher. Christopher gets them all and receives them, gets them out of the mail. Now, what he needs to do is, so it went down my stack and now back up Christopher's stack, he needs to reassemble and reattach all this stuff. And because I've numbered them, he can look at them and say, oh, I didn't get 15, you need to resend me 15. The unit of measurement used here is segments or messages. And this layer contains both connection-oriented or connection-less connections. So if we look here, connection-oriented communication, this requires both devices involved in the communication to establish an end-to-end communication. And I see Christopher smiling over here. I think he has something pretty exciting for us.
These are two of my favorite slides to have built. This was actually kind of fun for me.
So let's see what we have here. So at this point, okay, so the PC is basically, hey, I'm a PC, I'm going to need services. The server, hi, I'm a server, it makes an acknowledgement. I want to send you something important. Okay, I will watch for it. So we have this back and forth communication that's a connection-oriented communication.
We're aware that something's going to happen. We're making sure it happens correctly and properly and in order and in time.
And again, as we mentioned, packets not received can be resent.
Yep.
So now let's look at connectionless. So connectionless, end-to-end connection is not necessary before data is sent. So connection-oriented, maybe I'm looking at a file transfer. Maybe I'm looking at a web page. Connectionless would be streaming a video. I don't necessarily need every frame, but I do need certain information. So that information is kind of sent. We go back to our radio analogy where somebody's just talking. They don't know if the message is getting received or not. They're just sending the information out. That's kind of a connectionless communication. Every packet is sent, still has a destination in the header, but we don't necessarily know if it's going to be received. So here the server, I have communication for you, listen to me. And here the client's kind of sleeping because there's no response.
They're just listening. Server sending it out. Hopefully someone's listening.
Yep. So connection-based protocols. The transport layer contains both connection-oriented and connection-less. We have TCP, Transmission Control Protocol, that provides a connection-based system, and UDP, which provides a connection-less, unreliable transport system. TCP and UDP, so TCP transport's used for logging in, file and print sharing, replication. So basically, when you need acknowledgement, you use TCP IP. UDP is used for one-to-many communications, broadcast, multicast, IP datagrams, audio streaming, things of that nature that don't need to be acknowledged.
Yep. Hopefully someone's listening, and if things get dropped in transit. This is actually a protocol used in situations where packets can't be resent. One of the best examples I have of that is VoIP, voice over IP. If I have a phone that's working on an IP network and I'm having a conversation with somebody anywhere else, if the packet that I'm creating by talking into my device that's getting assembled and run through the layers and sent across the wire, if that packet doesn't make it, I can't re-have that millisecond of the conversation. It's just gone. So
otherwise you get chop, jitter,
yep, which you'll hear.
Stutter.
You'll hear gaps, and that's because there are packets that may not make it for any one of 1,000 reasons, and if they don't, there's nothing you can do about it.
Well, and there are certain things that, say a conversation. If, as Christopher and I are having a conversation, I have to acknowledge every word he says, that's really going to delay the conversation. Versus we go to a more connectionless system where he can speak long sentences and then I can respond in long sentences. That's more of a connectionless system where he's hoping I'm getting most of his words and I hang on 85% of them. And he probably hangs on 75% of mine. I'm not sure, but so
we'll go with that. Is how much of it I'm remembering.
So keep in mind there's certain overhead to a connection-oriented system.
Yeah.
So ports. Ports are a layer 4 protocol that a computer uses for data transmission. They're logical communication endpoints for specific program on computers for delivery of data sent. For example, we have two computers communicating. One computer is requesting web services from another. If I just send to the IP address a request for web services generically, it's not going to know how to respond to that. So what I need to do is specifically give it a port. I don't do that. The protocols do that. Give it a specific port to say, not only is it this address, it's this specific program I'm talking to. So go back to mail, our postcard analogy. Let's say Christopher and I have multiple postcard conversations going on. So I might address this postcard conversation as port 80, which is our term paper. Another postcard conversation we have might be port 443, which refers to some other conversation we have. So basically, ports allow you to not only say this specific device, but this specific application or process